This is Algebra 2, Chapter 5, Section 3, in which we will be studying polynomial functions. Now, typically, when we write polynomials, we'll put the terms in decreasing order. Put the highest power on the variable first, then the next, down the line. This is what's called standard form. Getting the polynomial so that the terms are in the order that we like is standard form. When we've done this, when we've got it into standard form, then that first term's coefficient is called the leading coefficient because it's the one out in front. Okay. So they're going to ask us to state the degree and the leading coefficient of the functions here, of the polynomials that they're showing us. Now we talked about degree back in lesson 1. It's the highest powered term that we have. So let's look at our first one. 8x5 minus 4x3 plus 2x2 minus x minus 3. Are they in the order that we want? 5, 3, 2, 1, and no variable. So they're in decreasing order. They're in standard form. The degree is the highest power we have, which is 5. And the leading coefficient is the lead number, 8. Okay. Consider our next one. 12x cubed plus 5x to the 6th minus 3x to the 4th minus 14. 3, then 6, then, uh-oh, that's not in the right order. Well, let's rearrange. So we need to rearrange it to get it in the right order. The 6th power is the highest, it goes first. 4th power is next, so it goes next, then 3rd, and then plane. Now we can read the degree. The degree is the highest power, 6. The leading coefficient is 5, because it's the first one in the line. That's why it's important to get it in the right order so that you have the right leading coefficient. Now they're going to throw some fun and games at us. They're going to ask us to evaluate f of 3c minus 4 minus 5 times f of c if f of x equals that stuff, x squared plus 2x minus 3. Okay. Remember what this notation means. F of stuff means you put the stuff, whatever is in there, in place of the x's over here. So I'm going to put the 3c minus 4 in place of these x's. 3c minus 4 squared plus 2 times 3c minus 4 minus 3. And then it says do minus 5 times, now put c in place of all the x's. So I did, c squared plus 2c minus 3. Now it's something we know how to clean up. We can do this. We just have to hammer through. And I'm going to take it a little bit slower here than I would normally do on my own page, but so that I can remind you of something important. 3c minus 4 squared means 3c minus 4 times 3c minus 4. Distribute this 2 here, and you get 6c minus 8 minus 3 from here. And then distribute the negative 5 to each term over here. Okay. Let's distribute this out. 3c times 3c, 3c times 4, negative 4 times 3c, and so forth. And all I did was just multiply these two out to get these first 4 terms. I didn't collect anything else. I just brought it all down. Now we can collect up. 9c squared minus 5c squared makes 4c squared. Negative 12c plus 6c minus 10c collects up to make negative 28c. And then 16 minus 8 minus 3 plus 15 gives us 20. I'm going to ask you to, as before, pause your video and work this out. It's a very similar problem, Work it out, and then come back and we'll check your answer. So our job is to substitute this 5a minus 2 in. So I did. 5a minus 2 squared minus 5 times 5a minus 2 plus 8, plus then 3 times plug a in, distributing the 3 and distributing the negative 5, reminding myself that this means 5a minus 2 times 5a minus 2, distributing that out, and then collecting up all of our terms, 28a squared minus 60a plus 46. Make sure you do this 5a minus 2 times 5a minus 2 and distribute it out. A lot of people will make the mistake of just saying, oh, it's 25a squared plus 4, and you're missing this middle term, these middle terms. So make sure you do it, show the steps, take the 3 seconds it will take to write out that extra line and do it. It will save you from a lot of problems later. Okay. Now, sometimes we can look at the graph and get a good idea about what kind of degree it has. If you go to the top of page 324 in your textbook, you will be able to see some diagrams of functions that have powers ranging from 0 to 5. So you can look at what these graphs would look like, and the number, the way it bends and back and forth, and the number of times that it goes up and goes down and things of that sort give you an idea of what kind of function you're talking about. Are you talking about a cube function? Are you talking about a fifth power function? Okay. Now, another feature that we can use looking at the graph is something called end behavior. Okay. It's the way the function behaves as we get way out into the far positive numbers on the far right or the far negative numbers on the far left. Okay. At the bottom of 324, same place I just referred you before, you can see the 4 possible end behavior patterns, along with the kinds of degrees and coefficients that lead to these behaviors. Now, if it's me taking the class right now, and I've got my note sheet in front of me doing this video, I'm probably, after the video, going to my book, going to page 324, and I'm making notes about that in this blank space that's down at the bottom of the page, so that you have it there in one place, and you have it available to you on the test and so forth. That's what I would do if it were me. Your mileage may vary. So what they are going to ask us to do is describe the end behavior of a graph, decide if we're looking at an even or odd function, and then state the number of real zeros. And the real zeros part is easy. Okay. First, let's look at the end behavior. When they talk about end behavior, what's going on as we get way out here, and what's going on as we get way out here, and way in the negatives, way in the positives. As x gets bigger and bigger toward negative, further and further toward negative, I should say, the function is going down. The way we write this is with the infinity sign. The function f of x goes toward negative infinity, because it's going downhill forever, as x goes toward negative infinity, off to the left. Okay. The function is going more and more negative as the graph goes more and more negative. On the other end, the function is going more and more negative, approaching negative infinity, as x gets more and more positive. This is what you're going to be writing for end behavior, stuff of this nature. And they have that on 324 there, so you can see what it looks like. Okay. The next question is, are we talking about even or are we talking about odd as far as the degree? If they both go the same direction, then we're talking about an even function. Okay. They both go down, goes down on both sides, so we're talking about an even function. The number of real zeros is easy to do. We just have to count how many times it crosses the axis. 1, 2, 3, 4. 4 zeros. Okay. Let's do one more of these so that we can talk about the other type. We have a new graph here. A bunch of ups and downs and all over the places. Okay. Let's talk about end behavior. As x gets more and more negative, what's happening to the graph? It's going up, 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 up. So f of x approaches positive infinity as x is approaching negative infinity. As x gets further negative, the function gets more and more positive. What happens at the other end? The function is going down, so it's going toward negative infinity as we get further and further toward infinity. Okay. Are they going in the same direction? No, one's going up, one's going down. That makes it an odd function. And the number of real zeros, hopefully you got 1, 2, 3. Okay. So you're going to be doing a couple of different things here. You're going to be finding me degrees and leading coefficients. You're going to be doing the fun plug and chug function stuff. And then you're going to be talking about end behavior and what that tells you. Okay. The information on page 324 is your friend. Again, I'm going to strongly advise you to put that on your note sheet so that you have it right there in front of you when you're doing your work. You've got the note sheet. You can see it. So that will help you along. As always, if you had questions, hopefully you wrote those down, bring them in with you so that you can ask me about them, and we will see you in class.